So welcome back. So more on the littoral drift. So again, based on the configuration of the coastal region and the wave action, this is what we term as a longshore drift. So here the wave action creates a longshore current near the beach that carries the sediments as long drift. So we have seen in the previous one, this is your beach drift where you have the swash and the backwash, whereas in the long drift you have the currents which carries the sediments as longshore drift along the beach. And the third one is the littoral drift where beach and the longshore drift carries and moves sediments parallel to the shore, similar to what you were looking at the longshore drift. And this process will result into extending the beach into the shallow waters of a bay area. So the beach drift and the long drift or the longshore drift, as you are looking at here, this is the beach drift and the longshore drift. So both of them, if are experienced in a region, then they will result into the extension of the beach into the shallow water, and such formation of the landform, which will also result in the formation of a enclosed area, which you can term as a bay area. And this landform, which will be an extending beach in shallow water, is termed as spit. So this is a combination of the beach and long shore drift. That is what we are looking at, the littoral drift. Now, as we have been talking about that the waves will play an important role. So the factors affecting the timing and the magnitude of the waves. So having the magnitude in terms of the height of the tidal waves. So mostly the tilt of the earth axis and the rotation of, or you can say the moon's orbit, will play an important role. So what it says that the earth and the moon system, a given point passes between a high part of one bulge during one part of the day and through a lower part of the other bulge during another part of the day. So this is what is been shown here. So one part of the day with respect to the bulge of the earth, whereas the second part of the day during the another portion of the bulge here. Now these bulges which are been shown here are not the same, and the tides will be created when the moon and passes through this region around the earth along the orbit. So what happens is that when the high part of the one bulge and the lower part of the another bulge during the day, two high tides at a given point are not the same. So the height of the waves will vary. So you need to keep in mind this part, that wave heights are not the same at each and every location on the earth, that is along the coastal lines. So the moon's orbit, the moon progresses in its 28th day orbit around the earth in same direction as the earth rotates. So the rotation is in the same direction. High tides arrives 50 minutes later each day because of the difference between the time it takes for Earth to spin on its axis and the time it takes the Moon to spin to the orbit or to orbit the Sun actually. So, the time difference of the rotation or the movement will affect the arrival of the waves, the high tide basically. So, these are the two important factors which will affect the tidal height and the timing. So, the timing and the magnitude will be affected because one is the tilt, that is with the tilt of the Earth axis and the rotation and its relation with the rotation of the Moon in its orbit. So, when the Moon orbit again will affect. So, the Moon progresses in its 20th day orbit around the Earth in same direction as the Earth rotates. High tides arrives 50 minutes later each day because this is because of the difference between the time it takes for Earth to spin on its axis. So, the Earth spin on its axis and the time it takes for the Moon to orbit the Earth. Now, because of this combination and because of the location of the Sun and the Moon, what we see is the extreme tides, and these are termed as spring tides and nip tides. So, when the Sun is on the same side as the Moon, so if you are having the Sun and the Moon are on the same side, okay, when the Sun is on the same side of the Moon, we experience extra large tides. So, this tides what we experience are because the Sun's attraction adds to moons, and this is termed as a spring tide. And this Sun gravity is another factor when the angle between the direction of the Moon and the direction of the Sun is 90 degrees. So, if the direction is like the angle is almost 90 degrees, then we say that at this point, and the relation between these two will result into the nip tide, and this is because of the gravitational attraction counteracts the moons. So, these are few things or the parameters which plays an important role in generating the global pattern of tidal ranges. So, different location depending on the relation between the location of the Sun and Moon as well as and with respect to the Earth, and the configuration or the location of the oceans and the configuration of the coastline, what we see is different tide levels. So, here the tidal range indicates are the spring tides. So, you have the blue ones, the blue patches are been shown the macro tidal ranges or the spring tides greater than 4 meters of height. Mesotidal is 2 to 4 meter and microtidal less than 2 meters. Coastal processes and associated landforms. So, coastal landforms depends on the coastal erosion, transportation of the sediments eroded, deposition. Coastal erosion dependent on dimension of the waves, configuration of the shape of the shoreline, strength of the wave eroded, and angle at which it meets the shoreline. So, this is what we were talking about, that the coastal configuration is extremely important. Depending on the above parameters, following landforms can be seen: headlands, sea cliffs, natural bridges, sea stacks, and tumbulos. So let's see a few examples of the erosional coastal landforms. What we have is sea cliff, and second is shore platform, notches and sea arcs, caves and marine terraces, stacks and wave cut benches. So these are a few examples of erosional coastal landforms, and as we discussed in the previous slide, that these all landforms are again dependent on the wave action and the configuration of the coastal areas. So this shows the example of these are the sea cliffs because of the erosion. Again, this is an erosional landform. Caves are also in erosional landforms, and the sea notches are also the erosional landforms, and stakes which are isolated. So if you see one by one, so what you have here is this part. These are the weathering by salt crystals, growth and wave action undercuts the sea cliffs or headlands, forming notches. So these are the typical sea notches, and such notches can also be formed because of the wave action. This we will see in the next coming slides. Then second is the weathering and erosion excavate the notches further in a weak rocks to form sea caves. So on the earth's surface or the land area, not yet, if we are talking about this dissolution activity, then such caves are been seen mostly in the limestone areas, but in the coastal region also we see the solution activity and the formation of caves inland or on the onshore side, and that could be related to the weathering, that is in dissolution activities, or by the erosion close to the coastal regions. And the third, what we see the headlands. So headlands is attacked from both sides. The notches connects and to create a passage, and these passages are what we say is the sea arcs, and stacks are again the left outs. So finally the top of the arc collapses. So if this collapse, this portion, then what you will see is the formation of the left out of this pillar like column like structure, and these are been termed as sea stacks. So this is an example of the sea cliffs and the sea stacks. So earlier probably there was an arc here, sea arc, which is collapsed and resulted into the isolated columns which are standing in form of an stacks. Okay. So you have sea cliffs and these are all stacks. Again the same sketch which showing multiple examples of arc, headlands, sea caves and sea stacks and cliffs. And one important thing which you can note it down here is the such flat surfaces are also been termed as marine terraces. So in some locations what we see is there are multiple steps which are been seen along on coastal zones, and those are indicative of the paleo or the ancient marine terraces. Now if you look at in the Andaman part, what we have already discussed this in the the plate tectonics, that this is one of the most active zone, subduction zone, Andaman Sumatra subduction zone, and along this on the eastern side we have the islands, Sumatra Islands, and then from this place we get into the islands of Andaman and Nicobar. So a dramatic land level change was experienced or noticed during the or after the 2004 earthquake, which shows that the southernmost tip of India, that is your Great Nicobar, subsided by almost 2 to 3 meters, and then similar subsidence was also experienced further north at Car Nicobar 1.5 to 2 meters, and the subsidence was also noticed as 5 meter here, and further uplift and subsidence which has been shown here with respect to the zero pivotal line. So the eastern side subsided, whereas the western side of the Andaman coast uplifted, and the uplift figures are been shown here. So upliftment was at the rate of almost like 1.3 meters or so, whereas the on the western side, the eastern side of this zero line, it subsided almost by 50 centimeter, and this was because of the 2004 Sumatra Andaman earthquake. So coming to this part, this shows the trench and the location of Andaman Island, and the deformation zone over here. There is a Google picture. So this is the trench area, and this portion what we see is been shown here. So you have the uplifted or the growing island here, and then further another bunch of islands which are sitting away from this. So this both of them, they got affected in a different pattern. So we'll see the example from this too. So the sea notches in this region, so first the western portion. So what we saw here, I will discuss quickly. So these are the usually the sea notches normally are formed because of the erosion. So weathering as well as erosion in the coastal zones will result into the formation of sea notches. So the wave action which will come and meet the land part, and if you are having the land area is rocky area, then you will have the erosion. So the cliffs will form, and that same cliff over the time will be eroded in a form of such arc which has been shown here, and that will result into the formation of sea notches. And of course further erosion will also collapse the hanging part portion here, as it been shown in this figure D, and again the sea cliffs will form, and then further erosion will take place. So what we have is the sea cliff here, and the constant erosion of by the wave, where you can see this portion is the low water line or the low tide level, and this portion of erosion is the high water or high tide part. So high tide reaches up to this one, and this remains the mean sea or the mean tidal level, and this is low one. So the low tide keep on eroding this portion, high tide keep on eroding this portion. So this arc shape or C shape form is formed because of the erosion, and the bottom portion here what we see is termed as wave cut platforms. So suppose such evidence of the cliff, the wave cut cliff, sea notch, and is been seen in such a fashion where we have the one platform and we have the present platform here, and we have one older cliff and the sea notch, and the younger cliff and the sea notch. So this clearly indicates that this was the portion which experienced the paleo sea level, or the ancient sea level was up to this place. So this is an older wave cut platform, and present day wave cut platform was this one. So this can also be correlated either with the tectonic uplift, where the land has moved up and the sea level remain the same, or the sea level fall because of the eustatic sea or the variations, or this eustatic sea level, which is climatic conditions because of the fluctuating climate. So this is one of the prominent landforms which are seen along the coastal zones. Now this portion, as I was talking about from Andaman, so this is the island Neil Island, which is located on the eastern side of the main Andaman, and very beautiful island. And as I was talking about, that if you go to Andaman, or if get a chance to go to Andaman, I think it's one of the worth place to visit, because it has a wealth of information and textbook examples of the coastal landforms, and also it preserves the history of the tectonic movement which has occurred along the Andaman-Sumatra subduction zone. We will try to discuss this in detail in the next lecture, and I try to wind up this one here, and see you in the next lecture. Thank you so much.